So basically, this entire course module. So, like I am covering it as a AZ 900, AZ 104, as well as AZ 305. So just to tell you what exactly it is. So AZ 900, it's Azure fundamentals, where we will be studying about the different uh, services which are available in Azure for us. So next is the AZ 104, which is a Azure administrator course. So here we will be studying about like how we can administrate the different Azure services which are available to us, and AZ 305, which is a solution architect course. Here we'll deep uh, dive into the different aspect we have. Like how we can design the solution, the different design principles, and there are some advanced topic that we will be covering. So altogether, there are 13 modules here, and these 13 modules cover all of these three courses. So at the end of the course, you will be able to understand, and you'll be able to demonstrate your skills on the Azure, on the different services which are essential to secure a job, or if you are already having some knowledge, it will enhance your current skills and expertise with the Azure portal. So we will begin with the first module, which is the introduction to the cloud computing. So it is essential that before we can understand what exactly is the Azure, and what are the different services provided by the Azure, we should understand that what exactly is a cloud computing, and before cloud computing, how the IT companies they used to work. When I say they used to work, I mean to say like what was the infrastructure model before the cloud computing emerged. So I'm talking about like the 2000s, or the early 2010. Okay, so and we will cover like how the what was the traditional IT setup, and what was the problem associated with that. Then we will also have a glance about the virtualization, and we will get to know how this virtualization triggered this new revolutionized technology, which is called as the cloud computing. And in the cloud computing, we will understand the basic foundations of the cloud models, which are IaaS, which is infrastructure as a service, software as a service, and platform as a service. And in the same module, I would demonstrate, or I will explain you how you can create your free Azure subscription. Okay, so usually, when you create your free account, so you will be getting a 30 days trial period with 16,000 INR credit in that. So you can do whatever you want within a 1 month. And let us say that you exhaust that limit. So then you have to upgrade your subscription to something called a CPI as a go model, which is a paid version. Okay. So, and we will also cover like what are the different SLAs provided by the Azure, the support plans, etc. In the module 2, we will study about the storage account as well as the ARM. ARM is nothing but the Microsoft Azure Resource Manager. So we will, I'll explain you so how this ARM plays a crucial role in accepting the user's API request, and creating the resources for you in the Azure portal. And I'll explain you what is the Azure storage account, the different types of storage accounts, etc. And this is something called as the service provided by the Azure. Okay, so when I say the block storage, file storage, it is nothing but the different services provided by the Azure. So in the module 2, it will cover this entire module. The storage module. It is split into two parts, which is the module 2 and module 3. In the module 2, we will cover the all the different types of storage services available for us. And in this next part, which is the storage account module 2, it's an advanced topic. Here we will cover the advanced topics such as the security aspect, which covers this the SaaS token. We will study about like how we can back up our data, how we can import and export data, etc. The module 4 and module 5, this covers something called as the computing service. So when I say the computing service, it is nothing but your virtual machines. So if you guys have idea about virtualization, you might have come across this term, right? Something called as the virtual machine. So we will study about the virtual machine, and we will focus on creating the Windows virtual machine, but I'll also explain how we can do it with the Linux VM as well. So in the module 2, we will cover the advanced topic of that. So such as the custom images. So you can consider the custom images as your operating system as of now. So no worries, like when we go into the module, we will cover all of this aspect deeply. Okay, so we can, and I'll also cover like how we can back up a VM and during some uncertain situations, like your VM getting corrupted, etc. So we'll study like how we can restore our virtual machine from the existing backup. Mhm. And the module 6 and 7, this basically cover the networking part in the Azure. In the networking one or the module one, we will cover the basic fundamental building block of Azure networking concept. We will study something called as the VNet peering. So when I say the VNet to VNet peering, it is like if you are having the different networks. So we will this would help these two networks to communicate with each other. Okay, so let's say that you have a virtual machine in a network one, which is totally isolated from the virtual machine in the network two. Then there should be some mechanism, right, that they should be able to communicate. So this is something which is happens in our real life uh, project cases. So you might be aware of that. So in that situation, how we can tackle that situation, etc. It's a solution provided by the Azure, which we call it as the VNet peering. So the connection gateway, it is the same as the peering, but connection gateway, it is a old method where the Azure provided as a solution to connect the two different networks, and peering is the latest technology which is introduced by the Azure. And I will also explain about IP addresses, and I will explain how we can, and I'll also explain in detail about subnetting part. In the module 8, it covers something about Azure Active Directory. So Azure Active Directory, it is responsible for your users management, your infrastructure management, etc. So each and every IT company is having the Active Directory. You might be aware of that, right? So if you go to your corporate environment and if you log into your laptop or the desktop, then in the backend, this is the component which is responsible for that, the Active Directory. So it's usually, I mean, it was developed by the Microsoft itself, and usually we have it on the on-premises, but the Azure has also provided this service on the cloud, and we will get to know what are the advantages of the Azure Active Directory over the classical Active Directory, which is on-premises Active Directory. We will study about the different rules. What do we mean by tenants, domains? Then we will also cover about multi-factor authentication, the RBAC rules, etc. Monitoring, it is essential, or it's essential for any IT company because without monitoring, you won't be able to predict what exactly has went wrong with your infrastructure, right? So suppose let us say that if you are having some applications or the infrastructure, if it has reached certain threshold limits, for example, CPU reaching 90% or 95%, etc. So there should be a mechanism for you to be aware of that so that you can take the prompt action and you can avoid the failure of your resources or your application. So for that, we have the Azure monitoring, and you might be aware that there are a lot of third-party monitoring tool as well. But we will compare and we will study like how Azure monitoring is distinct and unique, and what are its various benefits and advantages when compared to the other monitoring solutions. Module of AC104, we will cover something called as Azure App Services and Container Services. I hope all of you have heard of, I mean, at least came across the tool or the technology called as the Kubernetes, right? So we will not get deep inside the Kubernetes, but we will cover the basics of the Azure provided Kubernetes service, which we called as the AKS. We will study the container services and the Azure App Services. Azure App Services is a platform as a service provided by the Microsoft Azure, where you can host your web application, etc. So you do not need to worry about creating your virtual machines or managing that. Readily available infrastructure would be provided to you with Azure. You just need to deploy your application. I mean, obviously, you have to do the coding, testing, etc. by yourself, and you have to deploy your application. So this is very advantageous for some startup companies, or if your project requirement is such that they do not want to maintain the infrastructure, or they do not want to, I mean, hire more number of resources just to manage the infrastructure part and work. So Azure App Services may plays a crucial role, because you do need not to worry about managing your backend infrastructure. So everything would be handled by the Azure. You just need to write the code, and you need to deploy it on your Azure App Services. Before actually covering what exactly is a cloud computing, or for that matter, what exactly is a Azure cloud computing solution, we should be knowing what exactly the IT industries looked like before 2007, or before that, before this virtualization technology, or the cloud computing technology came into the picture. Okay, so in a traditional sense, your IT infrastructure, it was completely hosted on-premises environment. Now you might be wondering, like, what exactly is an on-premises environment, right? So on-premises environment means, say, if I have a company, and like, if it is a small scale of infrastructure, so you might came across, I mean, you might have gone to some offices and all. So there they would be having some dedicated room called as a server room, right? And they would be having a dedicated room for that, air-conditioned room, and they will be having some big racks where a set of the servers are mounted. So that is what we call it as the on-premises environment. So when I say the infrastructure, so I explained, I mean, I just gave you the idea about what is the on-premises infrastructure. But when I say the infrastructure, what exactly I'm referring to that, right? So that we should understand. So for IT company to go, we would need the infrastructure in the sense, let's say that a company is providing the IT services, like your web hosting, or application services, so on. For all those, we require certain computing infrastructure, which we refer to as servers, right? So we also have something called the server computers, to be precise. Yeah, I am sharing my screen. So, no, no, as of now, no, it's just a whiteboard I have shared. So nothing else. So basically, like all of the IT companies' infrastructure, they would be hosted on something called as a server computers. And now you might also be aware of something called as a personal computers, right? Or the I can say it as the laptop, desktop, etc. Now, comparing it with the servers, now let us understand what exactly is a server. So server is nothing but a powerful the computers, not like our the personal computers. The servers are the powerful computers which runs 24 into 7 into 365. I mean to say that across the entire year, they would be running, and they would be providing the solution. So the nature of today's business is that the server should be available across 24 hours, right? For example, let us say that you have the banking application. It could be any banking application, the HDFC, ICICI, or any banking application. So obviously, as a customer, you would expect that that banking application to be available for you across the year, right? For example, you might want to do some kind of transaction and etc. And during that time, if that banking application is not available, or they say that it is not uh, accessible right now, then obviously what happens is that would be ditching that bank, and you would be opening your bank account in somewhere else where they provide a better services, right? So that should not happen. So that is the purpose that all the business solutions, they need their entire infrastructure, or when I say the infrastructure, you can, as of now, you can consider it as a server. That should be up and running across the year. So since they are continuously running, obviously, just give me 1 minute, okay? I'll be back. Sorry for the trouble. Yeah, I'm back. Sorry. Yeah, so I was talking about that your infrastructure that should be continuously running across the year, so that any kind of services or the application, it will not be disrupted. And if that happens, then obviously the business would be facing some revenue issues, or the customer would be leaving them and joining or partnering with their rivals, right? So since these servers running continuously, they should not be having any interruptions, or it should not happen that, okay, anyone can come into the data center room or the server room and can interrupt this running services. So there should not be any other issues like the power outage issues, or during the rainy time, if there is any kind of flood issues, if the water enters to the server room, then obviously your the component or the servers will be damaged, and ultimately your application will be going down, right? So that should not happen. So that should be it should be protected from all of the interruptions that could happen. So for that reason, usually the servers or the infrastructure, they need a dedicated space, which we call it as a data center. Okay, so this data center, it can be entire building. I mean, the entire building or the entire office premises you can consider. The data center can be the entire building, or like I said, it could be a simple room in your company. So you might have seen that something called as a server room, right? So the data center is a one where all of your physical infrastructure would be hosted on. When I say the physical infrastructure, it is not only your servers, it would also be having your storage, like the SAN disk. You should be having the networking component, like the router switches, and many more essential infrastructure, whatever it is needed for your services to be up and running, right? So now in this data center, you will be having all the servers kept, and typically they are kept onto something called as a server rack. And onto the server rack, you have the servers mounted. Okay. So basically, the servers are of three types. First one, we call it as a rack server. Second, we call it as a tower server. And third, we call it as a blade server. In Azure, they mostly, when I say the Azure, I mean to say that the Microsoft Azure data center, they are using the blade server, and they also have a couple of tower servers, etc. Okay, so yeah, so this is about the data center, the basic idea of data center, and how it look like. So just to repeat, usually uh, there would be something called as a data center, a dedicated room, or an entire building where there would be something called as the server rack. You might have know this terminology, or if you know, I'll show the image as well. So usually you will be having some server racks, and on top of the server racks, or inside the server racks, the servers are mounted. So basically, these racks, there are of three types. So the rack servers, the tower servers, and the blade servers. So if we go to some Google Images, we can visualize it in a better way. So typically, this is how your the servers would be mounted. As you can see here, this steel frames. This is what we call it as the rack. So inside this rack, as you can see, this particular image, this is your server. So this server, I mean, it is not like your the normal desktop or the normal laptop, which is having the 32 GB, etc. So the resource requirement for the servers would be huge. So usually it will come up with the 64 GB of RAM and a lot of the cores, etc. And even the cost of this one entire server would be in lakhs. So that I'm talking the cost of one particular server. So as you can see in the second image, this particular person, he is mounting this particular server inside the rack. So this is how a rack setup or the server setup inside the data center would look like. Okay, now compare so the companies, when they have a requirement, let us say that, for example, a company who is into web hosting, when I say the web hosting, it is nothing but your web applications hosting, right? So it could be anything. So they have to host a website. Okay, so every time they have to host a website, they will take one server and they will do the deployment. Typically, when you want to host a website, you will have to have one powerful server taken for this purpose. When I say the powerful server, I said that you should be having a desired configuration, right? So whenever you design some application, obviously you will be having some desired configuration. When I say the configuration, so you might be, or when I say the your application might be demanding some RAM capacity, storage, etc. So you will decide upon that. You will do some analysis. You will do your application design, and you decide that okay, based on the performance or the potential performance of the application or the resource consumption, you will decide okay, this particular application would be needing let us say 16 GB of RAM and 4 cores of CPU. Okay, and once you have procured a server for your purpose, what you will do is that you will the next step would be you will have to install the operating system on top of that, right? Because these particular, I mean, these physical servers, they come up with the RAM, CPU, or the storage, etc., but they'll not be having the operating system installed. And without operating system, you are aware that it's nothing but a box, a piece of metal, right? So that's the reason that on the top of the physical server, you have to install the operating system. So typically, usually when I say the operating system, we have two types of operating system. So the first operating system, we call it as the server OS. And the second type of OS, we call it as the client OS. So the client OS is nothing but the operating system which we use on our laptop. Okay, so it could be like the Windows 10, Windows 11, etc. And when I say the server OS, these are the specialized operating systems that would be installed on the server. For example, if I talk about the Windows Server OS, we have something called as the Windows 2012, Windows 2012 R2. Then we have Windows 2022, 2022 data center operating system, etc. So these are some examples for the Windows Server. And talking about the Linux distribution, we have the operating systems like the Ubuntu, Red Hat, etc., or SUSE, Linux, etc. So there are various operating systems which are available for you. So I mean, going back to the example of the web hosting, so based depending upon your requirement and your client requirement, you would be either going for the Windows operating system or the Linux operating system. So once this particular operating system that has been installed on your laptop, So what you will do is that you will implement your website, or you will host your website on top of this, right? So this is what typically the companies used to do so far. So this is the concept of on-premises environment, right? So when I say the on-premises environment, I would be specific. It is a physical server on premises environment. Whereas, like for each and for each applications, you would be having some dedicated servers, and you would be having a dedicated resource requirement for that. For example, this many CPUs, this many RAM, and the operating system. And on top of that, you would be installing something called as the operating system, and you would be hosting your web application. So this is what typically happens with respect to the physical server on premises environment. Now let us see why did the companies moved on from this model, or like I mean to say this on-premises model, to something called as the cloud computing. Or we will cover exactly, or we will see why or how the transition occurred. So obviously, I mean, for this transition to happen, there should be some issues or the problems, right? Because for each and every transition, there would be some issues or problems associated with that. So if everything is running smoothly and properly, obviously, usually we do not go for any kind of transformation, right? So this particular physical server architecture, obviously, it has some problems with that, and due to that, we did I mean, the companies did the migration from the physical server on-premises environment or on-premises infrastructure to the cloud infrastructure. So let us see what exactly are those problems. Okay. So the first problem which the companies faced was the cost. Now let us see what exactly is a cost with respect to your on-premises environment. So you can say I just told you about what are the things which we need for our on-premises environment, right? So let's elaborate on that. You can see if you okay. Let us say suppose let us say that I mean you as an individual persons you want to start a company, right? And let us say that you want to do some web application hosting, or you might be having some application that you want to host, and your clients or the customers can use that application, and eventually that would bring the revenue further, right? Now, when you need to start your company, obviously you need to have some infrastructure, right? Because we need the infrastructure to host the services which we want. So first of all, now talking about the on-premises environment, so I told you the first requirement for that, right? You should be having some dedicated space or the dedicated area, which we call it as the data center, right? Because the data center is the one where you need to host your physical server. And apart from that, you need once you have acquired some area to build your data center, or let us say that you have rented out some building to keep your servers in that. The next step would be you need to procure the physical server. Then you need the storage for that. You need the network equipment. You need to do the cabling. You need the power supply solution, etc. Right? So, and I told you that this particular infrastructure or this particular servers, they are designed to run throughout the year. So if any electronics device, it can run for such prolonged time, what exactly it will happen? So can someone imagine, or can someone guess what would happen? Suppose let us say that I have an electronics device. So I mean, consider not only a server, you can consider your personal laptop also, or any other electronics device. Let us say that you run it continuously for entire year without even stopping for a second. So can you imagine what exactly is going to happen with your device?
Hitting it.
Exactly. So if you run it for such a prolonged time, obviously it will produce a lot of heat, right? So what would be the end result if there is a lot of heat? Obviously, the electronics devices, they can withstand the heat dissipation or the heat issues, but even they have certain the breakage point, right? If that is the case, what happens is that eventually they will break down or they will burn, right? For that, we need to control the heat dissipation, which this physical server or this physical components would produce, right? So, what might be the next solution? I mean, what is the solution to control that? So, obviously, you need to have the air conditioning system, right? Because I mean, suppose let us say that I mean, even you might have visited the data center sometime, or like you might have gone into the server room in the building area, etc. So you might have seen that the AC or the air condition, it would be turned on all of the time, so that it can be controlled. I mean, the heat can be controlled, so that your devices can be kept cool as much as possible, right? So apart from whatever we have discussed, that is the acquiring the data dedicated data center building, then the physical server components, we also need to have the cooling capacity also, right? So if you consider all of this, I mean, the area, then the servers, the network devices, then obviously the power supply, then the air conditioning, and you have to run it throughout the year, right? So obviously the cost would be extremely high. So suppose let us say that I mean you have a limited budget and you want to run this operation, then obviously your initial investment cost, it would be very huge. And it is not that you would be able to run your business with only one server, right? As I told you, so even the one entire particular physical server, I mean, even the low to mid configuration server, it would cost you around 4 to 5 lakh. Suppose let us say that your business requirement is such that you need to keep on adding the physical servers, then obviously your cost is going to increase exponentially. So that is not something you can withstand with your limited budget, right? So that is one of the main issue that you have. And apart from that, obviously you will be having some operational cost as well, because you need to, since you have the cooling solution, obviously your electricity bill, it would be high, and you need to pay for your ISP. I mean to say that your internet service provider, it could be anything, right? It could be Airtel, BSNL, Jio, or whatever the ISP you have selected. Obviously, you need to pay them as well. So comparing that, your cost would be very high, and it is, and ultimately you will give up, stating that okay, I have this limited budget, and it will not be possible for me to host this entire the data center. And even if you somehow manage to uh, adjust the budget, then obviously you need to pay for the operational cost. I mean, when I say the operational cost, it is a monthly bills that you need to pay, right? So when compared to all of this, the cost is something which plays.
Hello.
Yeah, hello.
I have a small question for this. For this subscription only free, or after that, suppose I want to log in Azure portal,
Okay.
afterwards it will get free or it will be chargeable basis they will charge.
The subscription, you will be getting it for free for the 30 days. It's a free trial.
Afterwards they are going to be charged, right?
If your subscription is a free, so even if you have exhausted your limit, they are not going to charge you. But the
Hmm?
thing is that you will not be able to host any of the Azure services. So
Okay.
yeah, so that is what is going to happen. We will do that at a later point of time, Yogesh.
Sure.
So yeah, yeah. So I was talking about the cost problem, which was associated. Yeah, Prasad, that is something even which I can't avoid, I believe, because there's a Zoom buttons actually. So what I'll do is that I'll try to overlap them, and I'll try to minimize this option. And So just let me know if you're not able to see anything because of this black boxes. Okay. Yeah. So we have we have talked about the costing problem, your initial investment as well as the monthly the bills which you have to pay, right? So we can classify this cost or we can classify these expenses into the two options. The first, we call it as the capex, and the second, we call it as the opex. So just to tell you, just for your information, when you are giving the AC 900 or AC 104, so usually you will come across at least one question on this capex and opex. So please listen carefully. If you do not understand, then let me know. Okay, so we have the cost is basically divided into two options. The first one is called as the capex, and the second one is called as the opex. So the initial investment, like we spoke about, for example, like setting up your the data center and procuring your physical components, etc. So that is what we call it as the capex or the capital expenditure. And OPEX is a operational expenditure. It is nothing but your operational expenses, right? So, for example, the bill, the electricity bill, the ISP bill, or suppose let us say that if you have hired any person to manage this infrastructure, then obviously you need to pay them the salary as well, right? So that and all, we can consider it as the operational cost or the OPEX. So capex is a one-time initial investment, as you can imagine, and opex is a recurring expenses uh, that you need to pay in a monthly basis or the annual basis, like whatever the option you have selected. So, but again, the operational cost would always be there, and it would be high uh, every time because as soon as you hire more people or if you are adding new servers, then obviously they are going to consume a lot of electricity, then the cooling, etc. Right? So this OpEx also it will start to increase as soon as you start. Your data center capacity increases. So this is the first problem which we have with respect to the on-premises environment, which is nothing but the costing problem. The Before moving on to the second problem, so if anyone of you have any queries or questions, then please feel free to ask them.
Hello.
Yeah,
Sorry to interrupt you.
yeah, sure.
Ashani, can you please explain more about the OPEX? It seems like I think OPEX is based on the subscription, what services we are using and what is we are paying for that. That
Ex-
comes under the OPEX.
Yeah, exactly. So, if we are just talking about the physical infrastructure, so OPEX
Correct.
is a one you can in a layman term we can call it as the monthly bills and the salary which we pay to the employees. So that we
Mhm.
consider as the operational expenditure. And the capital expenditure is nothing but the initial investment that you have made. So when I say the initial investment, for example, you might have bought a piece of land to build your data center, and you might have bought some physical servers, the routers, switches for your networking component, and obviously you might have laid out a large number of cables, etc., for the networking, right? So
Yeah,
that and all, which that is a one-time initial investment that you had made. So that for that we call it as the capital expenditure.
got it. Got it. Thank you.
Okay, no problem. Okay. Now, talking about the second problem which we have, it is called as the scalability. So what exactly is a scalability now? So the scalability is nothing but it's the ability to scale up or scale down. Okay. So for example, let us say that just to explain the scalability. So let us say that you have an application which is deployed onto your server. Okay, so we just spoke about the server, right? So and let us say that that application, it is having 8 GB of RAM and 8 core of CPU. So let us say that you have procured a small capacity server, which is having, I mean, just imagine that it is having some 16 GB of RAM and 4 cores CPU. And let us say that your application is consuming a lot of resources for due to any reason. It could be a heavy application, or there could be a lot of users interacting with your application, due to which, let us say that your the consumption of the resources, it is increasing. So initially it was at 2 GB of RAM, then now it is on 10 GB, and 16 GB is a cutoff memory, because your physical server, it is having a maximum sorry, RAM of 16 GB. Okay, so till here, let us say that it is a 14 GB of RAM. Till here, that is fine. There is no issue. But as soon as it start reaching the 15 GB, then ultimately when it reaches to 16 GB, obviously your application has consumed all of the available RAM for you. And usually what happens is that due to unavailability of the RAM, or it could be the CPU cores as well, what happens is that your application will go down, right? Because there is no other way for your application to switch from one server to the another server, or there is no way that you can increase the system capabilities of your server. So I mean to say that without stopping your physical server, there is no way that you can increase your RAM capacity or CPU capacity, etc. Or it may, or sometimes it might not be possible at all. So in that case, what happens is that your application is not able to scale up. I mean, uh, and eventually what happens is that due to the resource crunch, your application will go down, right? So that is the second problem that we have with respect to the scalability. I mean to say that your application won't be able to scale as needed. In that case, what happens is that your application will go down, and your end customer, or your end clients, they will be facing the outage of your application, which eventually damage your organization's reputation, as well as it would hit your revenue as well, right? So this was the second major problem which the companies were facing. So the third problem which we have, I mean, there are a lot of options actually, but a lot of problems. But the major problems are the cost, scalability, and the third one is something we call it as maintenance. So maintenance, in the sense, every IT infrastructure, they require to perform some maintenance, right? So I'm not talking about the physical hardware, the maintenance. I'm referring to the options like the operating system the patching, the application patching, or the installing some kind of kind of bug fixes, etc. So when it happens, obviously the server needs a reboot, right? Just to consider the operating system updates itself. So in your personal laptop, you might have seen that when the Windows do some kind of update, or if you are performing your operating system upgrade, obviously your system is asking for a reboot, and you have to perform a reboot. So when you do that reboot, what happens is that it is a downtime for your application, right? So today's industries, they need least downtime. I mean to say that usually during the SLA discussions, they would come to a conclusion, or they come to an agreement with their client, stating that, okay, my application will be having a 99.99% of SLA, which means that eventually that application will be available running, I mean, across the year, maybe for in a week. When I say the 99.99, so it's like 5 to 10 minutes of downtime is acceptable within a week or a month. But if you are periodically doing some kind of maintenance, etc., so obviously it is going to impact your SLA agreement with the client, and you will be penalized for violating your SLA agreement, right? So that is a third problem which the IT companies they used to face the problem when they were using on-premises physical infrastructure. So these are the three problems which we have with respect to physical servers. Now, in order to address this, the industries moved to some new technology, and that was called as a virtualization. So it's not a cloud that came uh, eventually after your on-premises physical infrastructure. So it is something, the virtualization was something that first came into the picture before the cloud technology arose. Okay. So the new technology that which the IT companies they adopted, we call it as the virtualization. So I hope you all of you might have heard of this terminology, which we call it as virtualization. So now what happens is that with the virtualization, you can leverage the underlying physical hardware, and you can create multiple resources on the top of a single physical server. So if you remember, while explaining the on-premises infrastructure, I told you that if you are having a one physical hardware or the one physical server, let us say that you were running application called as the app one. Okay. So if that is so, let us say that after some amount of time, I mean after some days or some week, you will get a second project where you need to deploy the second application called as the application two. So in that case, so usually what was happening with respect to the physical server on-premises infrastructure was it used to be hosted on the physical server two. This is server one and this is server two. But with the help of this virtualization, what you can do is that using the single underlying physical hardware, you can create multiple resources on top of that. I mean to say you can create something called as the virtual machines, uh, maybe the VM1, and here let us say that the VM2. And on top of the VM1, you have application one, and on top of VM2, you have let us say you have something called as application two, right? So in that case, what is the advantage you can in terms of cost is that, let us say that if this was costing you 5 lakhs and this was costing you again 5 lakhs. So instead of spending 10 lakhs, you can pay for only one physical hardware, which is costing around 5 lakhs, and you can deploy two virtual machine, and you can deploy two application on top of the single physical hardware. So obviously your cost has been drastically reduced, and there are a couple of more advantages which the virtualization provide with respect to the physical server infrastructure. Okay. So what exactly happens is that in case of virtualization, you will be acquiring a new physical server. Let us say that this is a physical server, and obviously for virtualization, you will be selecting higher capacity servers. So let us say that this is having 64 GB of RAM, and let us say 16 core vCPU, and obviously you need the storage solution as well, right? So let us say that the 64, sorry, the 2 TB storage solution. So repeating, this is a single physical server which is having 64 GB of RAM, 16 virtual CPUs, and 2 TB of storage. Now, in virtualization, if you want to virtualize your this particular physical hardware, you need something called as hypervisor software. So, is anyone aware of what exactly is the hypervisor software? Anyone heard of that hypervisor software?
Yes, it is used for virtualization, like VMware.
Exactly, that is right. So there are many hypervisor software. So we have like the VMware workstation. Then the Microsoft has its own hypervisor, which we call it as the Hyper-V, and or you can also use the Oracle VirtualBox, etc. So as I believe, like most of you might have aware of these virtualization softwares, right? So now you will use these virtualization softwares, which could be anything. I mean, it could be the VMware workstation or the Hyper-V, etc. And what you will do is that you will virtualize your underlying hardware, and you can create, and with the help of this virtualization hardware, you can create your VMs. Or when I say the VMs, it is nothing but your virtual machines. So this is exactly the physical server, which we call it as, or the physical machine. And on top of that, if you create computing resources or the virtual machines or the servers, we call it as the VMs or the virtual machines. And for this virtual machine, you provide resources, right? Obviously, when I say the virtual machines, they are nothing but they are your computing unit itself, just like your physical hardware. And they need to have the physical, they need to have the resources for them. When I say the resources, always remember, I'm talking about CPU, RAM, and network, CPU, RAM, network, and storage, etc. But how these virtual machines, they will be getting the resources from them? Obviously, they are mounted on top of the hypervisor software, and the resources are provided from this underlying physical hardware. For example, let us say that you have 64 GB of RAM here, right? So while creating the virtual machine, you might be specifying that, okay, this virtual VM need 32 GB of RAM. And for the second VM, you would analyze that, okay, this is a lightweight application and it might not need a larger capacity requirement. So you decided, okay, I'll provide the VM2 with only 16 GB of RAM. So you completely have the independence on selecting like what is the different resources you can provide to your applications which are running on the virtual machine. So that was not possible in your physical server, right? For example, if you're buying a physical server with a 64 GB of capacity, even if your application is using only 16 GB of RAM or the two-core CPU, so there is no way that you can isolate, or there is no way that you can reserve that capacity. So obviously you would be running one application and on one physical server, and the remaining capacities, like if you remove 16 GB from the 64, it's a 48 GB RAM still available, which is a wastage of the resources. So, but in case of virtualization, that is not the case. You using the hypervisor software, you will be creating the virtual machine, and it is you who is having the complete freedom to decide what exactly the physical, what exactly the resource requirement that I should assign for my application. So that is one of the advantages which the virtualization provide. Apart from that, as I said, the costing issue, that is also drastically reduced. So always remember that when I say the virtual machine, so each virtual machine, it acts as an individual machine, and it can host different workloads on these virtual machines, right? So, and all of these virtual machines, for example, VM1 and the VM2, they are completely isolated, and eventually they work like a separate physical server. So this technology, we refer it to as virtualization. And one more point. So suppose, let us say that you have the physical hardware. So let us say that you have installed the Windows operating system on that. Let us say Windows 2019 data center operating system you have installed. And let us say you have some Linux-based application. Okay, so there could be some application which use Linux operating system. In that case, what you have to do? Obviously, you need to create a separate physical hardware, and you need to install Linux on top of that. Then you have to mount your application on your second physical server. But in case of virtualization, so irrespective of whatever operating system, irrespective of whatever operating system the different workload or the different application require, so there is nothing to worry. For example, this virtual machine, this could be running on the Windows operating system. The second virtual machine, this could be running on Linux, and there could be third virtual machine that could be running on Mac OS. So that kind of flexibility, it is offered by the virtualization technology, whereas in case of physical server, you do not have that option, right? So as I said, with the help of this virtualization, now you have got many benefits. But before that, I have a one question. Okay. So what exactly will happen if this underlying physical server fails? So let us say that this is a physical hardware and you are having the two virtual machines that is running with the different workload. So it doesn't matter. It could be running on Windows, both could be Windows, or it could be a combination of the different operating system. My question is that what exactly will happen if this underlying physical server gets some issues, or it could obviously, since it's an electronics device, there is a high probability that it could fail, right? So can someone tell me what would happen to these virtual machines if this physical server fail?
The application may go down, and the services should be impacted then.
Exactly, because I mean, as I said, the virtual machines eventually, like they are getting the resources from their underlying physical hardware, right? So, I mean, even though you have the hypervisor software here, and on the top of hypervisor software, you have the virtual machine, but the underlying physical server itself, if it is getting failed, then obviously the virtual machine has to go down. So there is no other way. I mean, there is no other, I mean, I can say that the exception they can be getting, right? So obviously, the virtual machines, they would go down and there will be a downtime for your application. So if that is the case, do you think that you're going to deploy your application on the production environment with this particular setup? Is it advisable that, okay, I have one physical server, then I'll mount my two virtual machines with a different workload? Do you think that the companies would go for this particular setup? Of course, no. Because if you do this and if your server goes off due to any reason, then obviously there it is not going to work out, right? So let us say that you have a lot of clients who or the customers who are depending upon this particular application, and if you are having this setup, so this is something, I mean, like you are not even doing that. You should not even doing that for your development environment as well. So obviously, this method is not at all recommended, which if you are going to deploy your application in the production, or for that matter in any kind of environment. So in order to prevent this type of failure, I mean the hardware failure or the downtime in your environment, so we have a technology called as HA, or the high availability. Okay, so what exactly will happen here now? So you won't be stick to a single server. In the high availability concept or the HA concept, when this come into picture, the requirement is that you will not be stick to a single physical server, as you can see it here. Okay, so rather than you will be having two or more than two physical server for your infrastructure. Okay, so let us say that this is my first physical server, just like here, and this is my second physical server. And you will be deploying in your actual production environment, or for that matter, for your development or for the pre-prod environment, you will be going with the HA infrastructure or the high availability infrastructure. Okay, so now combining all of this, so let us say that I'll have one more physical hardware. Let's say that I have one more physical server here, and there could be some two virtual machines running here as well. Okay. Now, if I combine all of this together, we create something called as the cluster. So now you have something called as the clustered environment. So have you heard of this cluster or the clustered environment? Anyone of you might have.
Yes, we are. Yeah, we are aware of this.
Okay. So now what happens is that I'll tell you. So with the help of this cluster, so let us say that if your physical hardware is going down, okay, for some reason that could be going down. Maybe it could be the breakdown issues or the power is not supplied properly this issue. So let us say that this particular hardware is going down. In that case, what happens is that with the help of the clustered with the help of this clustered environment or the clustered high availability environment, and obviously for that you have something called as the cluster application. Okay, so there are various applications for that. For example, vCenter suite, we have the OpenStack. For the Azure, we have the Azure Stack as well. And you obviously going to need a license for that. And once you have this cluster application, what it will do is that in case of any failure in your backend, so these physical servers, I mean, these virtual machines that would be shifted to some healthy or the available physical infrastructure. For example, let us say that we have only two physical servers, and let us say that I have the vCenter suite as a clustered application for me. Okay, so what it will do is that it will automatically shift this virtual machine to your the physical hardware too. So in that case, what happens is that your application will not be having any kind of downtime, rather than like they would be running on your second physical hardware. And you will come to know that, okay, I have some issues on the first physical hardware. You can do the troubleshooting. You can go to your data center. Maybe you can do whatever it is required, and you can make this online available again, so that you can do that. But in that case, what happens is that with the help of the clustered environment or with the help of the clustered high available environment, your applications have been migrated to the next or the readily available physical hardware, and you have avoided a downtime. So this is what, I mean, this is the setup which we actually follow, I mean, which we used to follow during the virtualization technologies. So any questions or queries with that?
So again, worst scenarios like both physical hardware or physical servers can be failed. Then in that case, all
No.
virtual machines or the applications will fail, right?
Yeah, in that case, it will fail. But just to remind you, I mean, like just for the sake of explanation, I mentioned here only two physical server. But usually, your IT companies, I mean, when they had
Yeah,
adopted the virtualization, they would be having the multiple physical hardware. So there is
yeah,
obviously 0% chance that all the physical servers will go down until and unless there is some kind of natural calamities or etc. that has hit your data center. So apart from
yeah,
that case, it is not possible that all physical I mean hardwares will go down.
yeah. And even for the application availability, they have different instances on different servers, right? So they can also be made available. Uh,
Exactly. So that is
worst
what
case
we call
scenario.
it as the scalability. So your
Yes, yes.
one instance of application would be running on, let us say, the physical hardware one. And let us
Yeah,
say that we have a couple of physical server here. So maybe its second replica or the second instance would be running on the second virtual machine. So even if this is going down, your second, or you call it as uh, the backup instance, it would be acting as a primary, and it would cater all the user request and provide the service for your end customers. I would also want to explain something about uh, the SAN. I mean, just a basic introduction about the SAN, or the storage area network. Well, I'm just explaining you because like when we actually cover the Azure part, so you can relate that during that time. So that's a requirement. I mean, that's the only reason that I'm explaining all of this concept. So can someone tell me what is a SAN storage? Is anyone having any idea about what exactly is a SAN storage? Okay, no issues. SAN means storage area networking. Okay, SAN is a storage area networking. it is a storage service. I mean, just like I told you, right? For the physical, I mean, for your the compute to run, we have something called as the physical server, and for your storage solution, I mean, no, we are not talking this with respect to the cloud or the Azure as of now. I mean, we are talking with respect to the virtualization as well as the physical hardware only. Okay.
Actually, it is a network which provides a connection to different storages, right? Like,
The storage area network. So yeah,
yeah,
yeah, I'll explain that. So it's a
yeah,
storage service only, but it is connected to the network.
yeah,
So it's like your shared, I mean, you can compare it with your shared drive, right? So you might be having the
yeah,
shared drive configured for you, and the different the different laptops, etc. in the same. For example, in your project, you might be having the shared drive where your project details, your SOPs, etc. would be kept, and you can mount that particular shared drive on your laptop, and you can access that, right? So that is a kind of I mean, it's not, you can relate that in that way. So similarly, like storage area network, it is a storage that is connected to the network. Any server that is having the network connectivity can access this storage service. Okay. So what exactly I mean, you will do here, that while creating the virtual machine, you have the VM created, right? And for every VM, for storing their operating system, their data, etc., they use a particular disk. For example, if I open my laptop, itself, so consider my laptop as a VM or the virtual machine, and my data is stored on different drives here, right? For example, D drive, F drive, G drive, etc. So similarly, your virtual machines, I mean, based on, in case of the Linux operating system, we call it as a file system mounting or the file system FS mount. And in case of the Windows, we call it as a the drive mount, right? So let us say that we are talking about the Windows. So obviously, your virtual machine that should be having some drives to store their data. So data could be, if it is application, it's application data, and your individual virtual machines, or for that, even for that matter, your physical server also, they need to store their operating system data somewhere, right? In the Windows, the C drive is the default location for storing your operating system data. Now talking about the virtual machines. So for each and every virtual machine, obviously you're going to have the data disk as well as the OS disk. Now, when you create this clustered environment, or your virtualization environment, what you basically do is that you will be storing this disk on the physical server, or this SAN storage area network, okay, or the SAN storage. So this is what, and the disk of this particular virtual machine, we call it as the VHD. Okay, remember that for the virtual machine, whatever the disk it has, we call it as the VHD, or virtual hard disk. So in your laptop and all, we call it as a hard disk, right? So you are already aware of that. But for case of the VM, we call it as the virtual hard disk, or the VHD, and its extension would be usually in .vhd file. Okay. So what happens is that this VHD would be having the virtual machine's operating system as well as the application data stored in that. And if you need to have the high availability structure, you will be storing these VHD files in the SAN. Why? Because in case of, I mean, let us say that, I mean, in case of, let us say that you have, okay, just comparing this example only. Okay, so let us say you have the virtual machine 1 here, virtual machine 2 here. Let us say that you have some application data that is kept on the physical hardware. So it could be some critical data, right? I mean, application data, usually for your IT companies and all, the data is very important. So let us say that you have kept your VHD files in this particular hard drive. I mean, in this particular physical server drive. So what happens is that if this particular drive goes let us say that it is permanently damaged and it cannot be recovered. So in that case, what would happen? So the BSD file, whatever you had here, so that is gone, right? And if you want to switch your virtual machine from the faulty physical server to the healthy physical server, then there is no way that they can be mounted to the next healthy physical server. I'll tell you why. Because when this virtual machine is attempted to be started on the next physical server, it would be obviously it is going to need to have its data, the operating system data. The operating system data would be having its user credentials, its kernel information, the different the files which is required for application to be up and running, right? So if that is not available, even if you are somehow managed to make this virtual machine up and running on the physical server too, so entire application data it is gone. So our our goal is that your application would be up and available, right? I mean, if you're just moving your virtual machine from one server to the second server and making it available, but if your application data is corrupted or gone, then there is no use of making that, right? So in that, so for that is the reason that we usually keep the physical the BSD files in something called as the SAN storage. So the SAN storage usually how it will look like, it would be having some just like the rack, it would be we would be mounting our servers, right? So just like the SAN server, it would be having something called as the disk. We call it as the RAID disk. I'm not sure if you have heard it or not. We call it as the RAID, okay, or redundant array of independent disk, or the RAID
It
disk.
is it is block storage, right? Kind of block storage.
Yeah, it's kind of block storage, yes. So what happens is that, let us say that your virtual machine, once BSD5, it would be on the disk one, okay? And let us say that if the virtual machine to disk, it is stored on the RAID disk 2 or the disk 2. So now the scenario is that even if this particular physical server goes wrong, so your cluster software, which for example vCenter, so it is aware that okay, the BSD files are kept it on the SAN storage. So it would what it will do is that it will fetch those BSD files. I mean, and I mean it has some configuration mechanism. Whenever your virtual machines are mounted on your physical server too, they will get to know that okay, the BSD files are stored in this particular RAID disk, and they will access this particular RAID disk, and as well as the along with the virtual machine, even your application data would come up as expected. So just like your physical hardware, there would be a cluster of the SAN storages which are kept so that even they are high available. I mean to say that if you are going to have only one SAN storage, obviously, I mean, we cannot rely upon only one SAN, right? So we should be, I mean, we will be having a multiple SAN storages, just like your physical server cluster. There would be SAN storage cluster as well, which would be providing the high availability. So together entirely, we call this setup as the clustered environment, or and this is a 100% working solution. So before cloud computing technologies, etc., came, so the virtualization technology. So this is how the solution used to work. So that is what we have with respect to the virtualization. So we will, I mean, you will come to know, I mean, when we cover the Azure, you will come to know and you will get it why exactly I have mentioned this. Okay. So yeah, so with this virtualization, obviously the costing problem has been reduced, right? Because I do not need to buy hundreds of server. Maybe I can buy half of the service and I can manage that. The scalability problem that is also reduced. So let us say that if this particular virtual machine has reached the maximum capacity, obviously your cluster application, which is vCenter suite, it will eventually move it from one physical server to the next physical server where it can provide it sufficient resources. And the third problem, it has also addressed the third problem, which is the maintenance problem, right? Because let us say that, okay, if you're going to do some kind of maintenance activity, for let us say that you're going to upgrade your hypervisor software itself, okay, or your VMware suite. I mean, if you're going to upgrade your VMware hypervisor software, so you can plan that accordingly. You can drain your physical server. When I say drain, you can move your virtual machines from one physical server to the second physical server, and you can do whatever the maintenance activity is required. So all of these three problems are reduced by the virtualization technology. Yeah, NAS and SAN, it's kind of same, Durga Prasad. So usually we go for the SAN because SAN is having the RAID disk. NAS, it's a network area storage. It is not recommended for keeping your VST files, okay? Because I mean, usually it is used for your project shared drive. For example, if you need, I mean, just like I said, your project would be having some the SOPs details, the credential, not the credential file. We will not be keeping the credential files. The SOP files, or you might be having some the project related documents, etc. So for that case, you would be using the NAS storage. But SAN, it is a specialized storage which is used for your clustered application. Uh, so yeah, so that is what we are. I hope that is clear with you, right? Okay. But even though this virtualization had solved most of the problems, like I said, the cost, scalability for some extent, and for the maintenance, etc. So this is not a foolproof solution, right? So there might be some issue that, okay, let us consider only two physical server as of now, for the sake of explanation only. So let us say that we have two physical servers, each with 64 GB of RAM. Okay, and you have multiple virtual machines running on that. Let us say that your second physical server, the total memory consumed is maybe 50 GB. Not 50. Okay, let us say that 60 GB of RAM is already consumed on physical server two. Let us say that your application one, which is running on the physical server one, it might be having a lot of user interaction, and maybe it is uh, used by several users, and the resource utilization is going up. Okay, so there is no control. Okay, so and let us say that it has reached to the maximum limit, and now you need to scale your application, right? So let us say that here only 4 GB of RAM available for me, and on the physical server one, I do not have the sufficient memory. In that case, what happens? Obviously, it doesn't have any, I can say, the required resources, right? So in that case, the scalability problem would arise, and your application might not perform as expected, and there is no way that you can increase uh, its RAM capacity, right? I mean, you can do that. What you have to do is that you have to shut down your physical server. Maybe you need to take out your existing RAM, and you have to buy a new RAM with, let us say, 128 GB of RAM, and you have to insert that. But it is going to take time, and it's going to take some kind of downtime, etc., right? So again, even though virtualization has, I mean, addressed the scalability to some extent, but it has not addressed for 100%, right? And even though the costing is less, but still, if you are starting a new company, I mean, for a startup company, again, like you are going to purchase a lot of physical server. You still need to have a data center procured for you. You still need to have the power supply, cooling solution, etc., for everything for you, right? So there is nowhere that you cannot say that, okay, I don't, I mean, just because I have, I mean, just because the number of physical servers uh, has reduced, it doesn't mean that you do not, you can skip the capital expenditure or the capex, right? So the capex part is still there. So for all that reason, virtualization again was not widely accepted. I mean, it was accepted, but the companies then started to think that, okay, again, this is costing me something. I mean, even though it is better than the physical server, on-premises physical server, but still it is costing me some kind of capex costing, as well as obviously I need to pay the bills for electricity. I need to pay the bill for ISP, etc. So that is still there, right? So that is a problem which the companies still used to face with the virtualization technique. In order to solve that, we moved, I mean, when I say that the companies moved to the next revolutionized technology, which we call it as the cloud computing. Okay, so the cloud computing, how it solved the problem, the capex problem, opex problem, then the scalability, maintenance, etc. How it is solved, what are the some advantages, and what are the some possible disadvantages which we have, etc. with respect to the cloud computing. That we are going to cover the next Saturday. Okay. So this was a basic introductory class for today. I mean, it was kind of a demo session as well. So I'll be stopping it here for today. So before wrapping it out, do you guys have any questions, or do you want to have any topic that I need to repeat, or you have any questions? Then please feel free to ask me. If it is clear, can you please confirm in the chat stating that it is okay for you?
Yes, yes, Mohammed.
Yeah, thank you. So the next Saturday, what we'll do is that we will study from the second, I mean, we will learn the second point in the module 1, which is, okay, is cloud computing. I have covered these 2 points, right? So we will start with the cloud computing, and I'll explain what exactly is a private, public, and a hybrid cloud. And we will proceed as per the module. From the next Saturday for the actual class, the timings are from 9:30 a.m. To 1:30 p.m. And since it's a 4-hour class, I know that it's not possible for you to sit continuously for the 4 hours. So we'll be having a break as well in middle. And yeah, so please be on the time. Please log in on the time so that we do not, I mean, so that I can start and complete the module as expected, so that I should not be able to, I mean, so that, I mean, if you delay by 15 minutes, then I have to extend the class by 15 minutes. So I would request every one of you to be available by 9:25 itself in the morning. Exactly at 9:30 a.m., we are going to start the session.
Is 8:30 a.m. not possible?
Sorry?
8:30 a.m. not possible timing?
8:30 for I mean, have got to understand that, like, there are few people who are doing night shift. Okay. So
Okay.
they might be doing the night shift on the Friday. And in the previous batch, like they have said that, okay, so 8:30 is not possible for everyone. So that's the
Okay.
reason that we have kept it as 9:30. So 9:30 to 1:30.
Ashadit, I have a question. How will you provide the recorded session for the Saturday, Sunday, if possibility I missed any
Yeah.
class?
So so all these recorded sessions would be stored in NeoSkills shared drive. So they will be sharing you the drive's URL. So uh, from there you can download that. Maybe you have to initially you have to raise a request for them. I mean, when I say the raise a request, like when you try to click on that content, you will be prompted to provide your consent. I mean, not the consent exactly. You need to provide the request stating that you need that request. So once they approve that, from then onwards, you would be able to download the recorded session as you need. So yeah, that would be stored on the shared drive of new skill. So probably Kunal sir, he would be sharing you the URLs for the recorded sessions. Yeah, from there you can download it.
And one more request also. If someone is a miss this class, right, session, and will attend the recorded session, and if any having any doubts, so
Yeah,
will you
you can. Yeah. For that, like I said, I will be available. I mean, you can contact me over WhatsApp. I mean, even if you're doing some kind of demo by yourself, or if you have missed the class, and if you are not able to understand some points in the recorded session, you can reach me. I would help you. No problem.
Hi.
Yeah. Hi.
Could you please share that syllabus with us? So that syllabus PDF, so we
Yeah,
can
I'll share
check.
that. Yeah, sure. I will share that. Yeah.
Will help to understand which we have learned today or something. So yeah.
Yeah, sure. I
Yeah.
mean, you mean to say this PDF file, right?
Yes, yes.
Yeah, I'll share that. I'll share it.
And are you going to form any WhatsApp group with the participants who have
I think
finalized?
it's already available, right? With the name MS Azure 7 July.
Yeah, you can. Can you share this PDF on the WhatsApp group, or you will share it here?
Uh,
Actually,
I'll,
I'm not there on the WhatsApp group. I will request Garima to add me to that.
yeah, please, yeah. Please contact your point of contact. I mean, Garima or Shraddha or anyone like with whom you are interacting, and ask them to add you in the group chat. And don't worry, I'll share this PDF PDF in the WhatsApp group itself. Okay, so any more questions, or we can very good to this.
No, Shadid.
Okay, so thank you everyone. Have a nice day. It's a pleasure to
Thank you.
meet you guys. Yeah. See you next week. Yeah. Bye bye.
Yeah, thank you. Bye bye.